we're going to demystify a little bit of stuff today. Who's planted a tree before? Right. Who's done it properly? I don't know. I'll get to that.
Depends on what you.
Yeah, this is it. There's your soil profile, and you've got your tree. All right. So here's your tree. And you can buy a bare rooted tree, or you can buy a potted tree. Doesn't really matter, but the principle still applies. And the theories have changed. There's as many theories about planting a tree as there are probably people in this room, and that you've got more. The one I'm going to tell you is the best way. This has been researched and was actually established in the 80s. This is the actually best way to plant a tree. We'd love to tell you that you've got to go down to, depending where you go, if you're working a normal retail nursery, they really keen on selling you extra product. Love it. And so they'll tell you that you've got amendments in. By amendments I mean compost, fertilisers and all those sorts of things. Not actually the case. First thing is you dig your hole. Now if you've got a pot, we'll do a pot size for it. That's your pot and that's your tray. You want to make your hole about twice the size and about twice the depth of your hole. That's number one. That never changes. So you've taken all that soil out and you pop it over here and mixed it all up, etc. So you pop your tree in there. And typically we'd love to say you put your compost and you put your manures and things like that in there. Don't. Do not do that. Wrong way to do it. If you put manures in the bottom of the hole and then you water it, what happens to the manure? It starts to ferment because there's no air. There's very little air. Depending on what your soil's like, obviously if it's sand, you've got a better chance, but nonetheless, it'll actually start to ferment. When manure ferments, it starts to give off gases, and when it gets all the nutrient in that manure goes off into the atmosphere, it's gone. It leaves the system. Not a good idea. You want it for the tree, you don't want it for the atmosphere. And the other thing is, it also starts, as it ferments, it produces alcohol. Plants don't have livers. They're not like us. Alcohol is poison to the plant 1 part per million and will kill your root system. So do not put manure in the bottom of the hole. You can put a little bit, if it's a heavy soil, you want to break up and improve your drainage. Sand is really good. Fine scoria, really good. Break it up, mix it in with the existing soil and plant it there. That's a really good idea. But don't put things in like, you could put some compost in there if you've got a sandy soil. Compost, not manure.
What about gypsum?
Gypsum takes a very long time to work. Typically it takes 2 or 3 years before gypsum starts to work. Gypsum is an amendment you put in, it breaks up your clay, it flocculates your clays, it separates the platelets of your clay and opens it up. It takes a very long time to actually work. The other way to do it is what I'll get to in a second. The best way to do that. Any questions on that? No? Best way to do that is like once you backfill and you put your tree in there, and away you go. And your tree's got to be at the same height. So there's your tree, and you want it at exactly the same level. You don't want it any higher. Alright? Got to be at that level. And the other thing to think of with orchard systems, grafts and things like that, is you've now observed where your dominant winds are because you've been a good student and you've come along today and listened to them. And you've had a look what dominant winds you've got. And with a fruit tree, you've usually got a graft. So you face your graft into the wind. If that was prevailing wind, the graft goes towards, not away from it, because that's its weak point. It is possible that could break. And when you plant it facing into the wind. right? And at the same level. You can see that one, it's a little bit of a root there, right? There we go. So, and you just keep it pretty much the same level that you've got your plant at now. That's really important. Once you've planted your tree, then you can inoculate the area with compost. Compost is really good. If you've got your own compost, great, because it's got your microorganisms in it from your area. If you haven't, okay, go and get some. But compost is really important. I talk a lot about compost, and I'll go into a little bit of compost because there's a lot of new faces here. Why do permaculturists bang on about compost? We just love this stuff.
It's alive.
It's alive. The soil is living. It's not a dead. It's not like the stuff over here, potting mix. That's actually inert. It's got some bacteria in there, but it's largely inert. And it serves its purpose. But we actually inoculate that with compost tea. We make our own actual compost tea here, and we spray everything with compost tea, and that inoculates our potting with microorganisms. In a teaspoon of good soil, which is what you're aiming to actually produce here to get good fruit trees, you've got just a teaspoon. You've got 20,000 different species of bacteria in that one little teaspoon. That's what you should have in good soil. 20,000 species of bacteria. Not individual, species. You should have at least 5,000 different forms of funguses in that teaspoon. You should have probably 100 different types of microarthropods. This is what we call a soil food web. I covered that the other day for you. Microarthropods are like tiny little critters, and they actually eat the bacteria and the funguses for the most part. You should have 10 nematodes. Everybody heard of a nematode? Everybody thinks they're bad, they're evil creatures. No, very few. Most of them are really good. Most nematodes actually, if you didn't have nematodes in your soil, you'd get a bad soil. You want good soil. So nematodes, and then you might have one worm. Pretty big teaspoon, okay, to have a worm. But nonetheless, that's what you're looking for. That's the goal, is actually to make your soils productive. That's really what you need. And the easiest way to introduce that to your soil is compost, because a good compost should have those components in it. And so you put that actually on top. And you inoculate it. So if your soil's lacking in any of those sort of things, it's going to help the tree. Why do we want that diversity in your soil? Why does that occur? Why do we want that? Because it's going to help your tree. Trees have evolved with the microflora in the soils. And because trees are captive, you put a tree in the ground, it can't move, it can't go and get food for itself. The roots will go through the soil, and traditionally we think the tree is responsible, and it's the roots that are absorbing the soil, absorbing the water, and all those sort of things. The trees have worked out, in actual fact, we are only just coming to terms with this. Trees will produce they photosynthesize, and when they photosynthesize, they grow, and they're producing what when they photosynthesize? I'm taking you back to chemistry, I'm sorry. Oxygen. They produce oxygen. What else do they produce? Sugars. They produce sugars. Right? That's what they do. And they're sugars they convert, and that's how they grow. And that's why we want to eat them too. Sugars. But average plant, 50% of those sugars, so half of the production of this plant isn't available to the plant, but actually half half of the production of the plant goes into the root system. It's pumped into the soil. What do you reckon?
In order to support the structure above the soil.
Exactly. It's feeding it's feeding the bacteria and the funguses and the microarthropods. It actually feeds all those guys. Not so much the micro, but certainly the bacteria and the funguses. It's actually, so half of the production of this plant goes in to feed those guys. And in return, we've got I'll draw a root for you on the cellular level. Roughly. Right. A little mitochondria. That's a very fine root hair. Right? And we'll have a fungus. Now, is it a fungus? We'll draw a fungus. That's a fungus. Funguses will actually implant themselves directly in and occupy one of the cells or a series of cells within that root hair. And once the fungus has made that connection with the plant will feed the fungus the sugars. Mm-hmm. Right?
Yeah.
Because funguses can't produce sugars. Very simple. And in return, the funguses will go out, but they have the ability to go and break down parent material. They can break down rocks, they can break down vegetation. And so they can then feed that directly back to the plant. So it's an exchange program, mutually beneficial. Right? So, yeah, really, really, really necessary to have that amount of different funguses in the soil. Because with that diversity, this fungus could be particularly good at breaking down and producing phosphorus for the plant. Another one could be very good at getting nitrogen for the plant, something like that, or moving it around. In 1964, some researchers in America walked into an old growth forest and they cut down a tree in an old growth forest. And into the sap stream of that tree, so there's a tree in the forest, and into the sap stream here, they actually added radioactive potassium and radioactive, two chemicals anyway. And they came back 10 days later to see what the results were. So they've drip fed this poison basically into the top of the tree. And they came back 10 days later and they monitored through Geiger counters where that material had actually moved in the forest. So we've known this stuff for a while. This is 64 that we did. And they found that the material had actually moved 10 metres away and was present in the other trees in the area. In
How many
significant
days was that?
concentration.
10.
How many days?
10 days.
10.
Wow.
So within 10 days, that nutrient had moved into the forest system as a whole. But it wasn't just in, if that was, say, an elm, it wasn't just in all the elms. It was actually in about another 10 different species around the forest. It actually moved. And what had happened, see, we like to look at gardens and things as everything is in competition with everything else. Forests actually don't work that way. They all support each other. So what you'll find is there's two mechanisms at work here. The roots of the tree have gone out and they'll actually have another root in the soil of a elm or birch or something like that, and they actually join. They'll join with a different species of tree altogether, and they'll share nutrients directly, and water, and whatever else the other plant needs. Because overall, in a forest system, it's self-supporting. It is beneficial. If everybody's doing well, the forest does well, I do well. Makes sense. And so that's one way they do it. The other way is funguses. Fungus is going into the root systems and moving things around. I've planted my fruit tree here, and I have a pile of compost over here. Some of that nutrient will leach into the ground, and a fungus will pick it up and actually transport it to my tree for me, if it's available. The root system may not go all that way, but the funguses are far, far better. The surface systems of fungus is far better at distributing things than any root system ever will. They go further, they're right through the soil. They're quite remarkable how this whole system works. And that's why we want to have a good, healthy soil.
That's the mycorrhizal activity, I think.
Mycorrhizal, yep. If you want it, yeah. It's a type of fungus, it's called mycorrhizal, and it actually goes right around that root hair and completely cover that root hair. What's another way that funguses benefit plant roots? Is I've got a plant root, I've come along and I've just planted my fruit tree, which I bought from the nursery, and it's been hasn't had any compost tea on it. You haven't got any compost. It's been growing in potting mix and been getting chemical fertilisers, which we do not do. And so you put that in your soil, and it hasn't got any protection. There's no funguses, there's no bacteria, or very little around that actual root system. And you buy another tree that maybe has had those inoculums and been grown in compost. You put the two in. Which of the root-eating nematodes going to eat?
The non-protected one.
The non-protected one. Because as soon as you, a root-feeding nematode is like a worm, if anybody doesn't know what a nematode looks like. We'll go, and it can't even find this root. It's completely covered with spaghetti, with fungus. It doesn't even know the root's there to eat. Right? In an unprotected one, you'll see this in tomato plants all the time. You buy a tomato plant, you put it in, next day it's back, dead. Something's taken it out. Right? When they've been grown badly with chemical fertiliser, you'll see it quite often. Any questions on that? All right, good. So, that's why we put compost on top of it. And so we take the lesson from the forest and we put compost on top of the plant. And you can put some manure there as well. If it's aged manure, that would be fine. But it's compost first, and then you put some material like mulch, those sorts of things. And it works more like a forest. You copy nature. And it's a lot easier. And we need to make it easier. So that's basically how you plant a tree.
Extremely late person wants to ask, did you put soil before you put the compost?
Yep.
Thank you, that was all.
No
Sorry.
problem. Yep. Yeah, we backfilled with the existing soil.
Thank you, sorry about
No, that's cool. No problem.
Excuse me, John.
Sure.
Just going back to compost.
Yep.
If you're starting, very briefly, if you're starting from scratch,
Yep.
what's the makeup of a good compost? Please.
Okay, no problem. A good compost. Well, to have a good compost, you need nitrogen and carbon. Are the two components for compost. Nitrogen and carbon. If you want to make there's all different types of compost. There's worm compost, there's hot compost, things like that. So you basically need a ratio of
25 to 1.
Yeah, it's about 25 to 1 exactly. So you need 25 to 1. Right. So you need more carbon materials than you do nitrogen. Right. What are the carbon material? Anything dead, anything sticky,
Oh, sticks.
anything brown, basically, is what you're talking about when you're talking about carbon. Anything green typically is nitrogen. Right. Grass is nitrogen, it's a huge nitrogen source. Right. That's basically, you keep it in that basic ratio. Right. Coffee grounds, really good nitrogen source. Bit of milk brown. Manure, another nitrogen source. So you put a layer of material and yeah. Is that sort of helping?
Yep.
Yep.
Just on the coffee grounds, John, would
Yep.
you just use coffee grounds in your garden?
Yeah, I do.
Yeah.
Coffee grounds are actually quite a good product. Yeah, they're very good. Loaded with nitrogen though, so be very careful. They can burn your plant.
Is there something you shouldn't put it on in the way of plants?
Not that I found.
Okay.
As long as you use it sparingly, because it is a there's almost like fertilizer.
Worm farm's not too.
Sorry, worm farms, yeah, really good stuff. And a worm compost, you don't have to worry about the ratio as much; they do the work for you.
Changing the topic a bit, but with the hole that you dug, how
Yep.
important is it to rough up the edges?
Good, thank you for mentioning that. Yeah, a lot of people, when you dig your hole, depending on your soil, if it's a heavy soil and you're using it, and you've got a very, you'll actually shave the edges, and it'll be quite. And we like to dig our holes, and it has to be really neat. You know, some people love that. No, rough it up down the outside, like little cuts inside. You give it smooth, it's not going to work as well for you. Just rough it up, so the roots will get in. It's like you're basically going to be planting in that. And the roots in potting mix and plants like that, they get lazy. And so they'll go through your nice new soft soil and they'll hit the slightly hard soil and stop. So you've got to rough up the outside of the pole.
So what if you have really heavy clay soils?
Yep.
And I found sometimes if I hit a real clay pocket, I'll actually have a vase there.
Exactly, it'll just fill up with water.
Yeah.
That's it.
How do you work with that?
There's not much you can do about that, except, which is the next thing I was going to. If you've got a really heavy clay soil, for a fruit tree, you're typically going to need at least, in the old measurements, 4 feet of good soil, good drainage, or else your fruit tree's just not going to grow well. You need at least a metre of good soil. If you haven't got that, you mound it up and you plant on top. When I say that, people go, oh yeah, and they make these little mounds about, it's a tree like this about that wide. No, I'm talking a mound, a decent hole, a decent thing. And that way, that's above the existing soil level, and you start to get that sort of thing. You've got to mound it up.
Excuse me, John,
Sure.
I did that, and it was like from over there to here.
Yep.
But I found my apricot kept having very much surface roots. They went for, a long way out. I don't doubt that it had up and down ones as well.
They will penetrate, yeah.
But the surface roots were everywhere, so I started planting bits and pieces on top.
That's exactly right.
Oh.
That's exactly right. If you've got, does that answer the question? That's the only way you can do it with an heavy soil. You've got to improve your soil, right? And yes, you can do that. I mean, you could do that with a whole mound of compost if you want to. But you want to muck this up too. You don't want to just mound your compost up on there. You want to dig up your existing soil and rough it up.
Will the compost eventually help to break that up?
Yeah. The best way to actually get a good soil is compost. All these guys are going to break up your clay soil if you get them in there. The quickest way to actually break up compost is with a good break up clay is with a good compost. Those things will actually work for your soil a lot better. They'll follow the root systems in. Sorry? No, they'll do the job for you. They'll follow the root system in. They'll break up the clay for you. That's how it works. That's what they're designed to do. Any other questions on that?
If you've got access to like a digger,
Yep.
and you just dig up all the clay and it's all broken up,
Yep.
will it sort of harden up again, or do you have to put something through it or anything like that? Or
I'd recommend, if you've gone to the trouble of doing that, certainly put some fine, typically you won't get sand these days, but the very fine scoria, right, that works well. And scoria is particularly good because it's quite a light material and it's also quite jagged, so you'll get you get spots for microbes and funguses to live. Right. What happens with a bacteria and bacteria in the soil, what they do is they form a little home. They form glues, and they form they get soil particles and they glue them together and make little hotels and live. And then nutrients flow past them and they grab them and hold on to them. And then the funguses come along and they actually pull these little hotels together and make bigger aggregates, soil aggregates. And that's how you make improve your soil. You get the biology back in your soil, the biology back in your soil, you will fix your soil. Without that, that's the quickest way to do it. Absolutely. There is only, I mean, you can put gypsums on, you can do all those sort of things. You want to do it on a permanent basis, that's the way to do it. Right?